Welcome to Review Central's UPCAT Reviewer number 5, featuring questions for the UPCAT Mathematics Proficiency subtest. This reviewer is intended for those who are eyeing, or are set to take, the University of the Philippines College Admission Test, or UPCAT. There are 10 questions featured on this reviewer. All questions are modeled on actual questions that appeared on previous UPCATs. Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Now let's begin. Question number 1. Which of the following could be the equation of line 2?
A. Y equals 2/3 x plus 1.
B. 5x plus 4y equals 0.
C. Y equals minus 5 over 4x plus 3.
D. 3x plus 2y equals 0. The correct answer is B. 5x plus 4y equals 0. Recall your geometry topic, 2 points and a line. We know the coordinates of 2 points in line 1, therefore we can find its slope. We've computed the slope of line 1, m1, as 4 over 5. Note that line 2 is perpendicular to line 1. From geometry we know that, if two lines are perpendicular, the slope of one line is the negative reciprocal of the slope of the second line. Therefore, the slope of line 2, m2, is the negative reciprocal of the slope of line 1, m1. From here we determine m2 to be minus 5 over 4. From the slope-intercept form of a line, we can write the equation of a line as y equals mx plus b, where m is the slope of the line and b is its y-intercept. We already know the slope of line 2 to be minus 5 over 4. From the figure we know that line 2 crosses the y-axis only at one point, which is at point 0 and 0. Therefore, its y-intercept b equals 0. With the values of m and b already known, we can now write the equation of line 2 as y is equal to minus 5 over 4x plus 0. 4y is equal to minus 5x. And finally, 5x plus 4y equals 0. Question number 2. Evaluate. The limit as x approaches the square root of 3 of the quantity x minus the square root of 3 over the quantity x squared minus 3. A. The square root of 3 over 6. B. 2 times the square root of 3. C. The square root of 3 over 2. D. The square root of 3. The correct answer is A. The square root of 3 over 6. With x being equal to the given limit, which is the square root of 3, we can write the function of x by substituting x with the square root of 3. We'll arrive at 0 over 0 as the answer. Recall from the limit of a function in your basic calculus, that when you arrive at a 0 over 0 limit, it is in indeterminate form. This means that we don't really know what it will be until we do some more work. So what should we do? We can try to transform the limit expression by multiplying it by the quantity x plus the square root of 3, over the quantity x plus the square root of 3. Take note that we are not actually changing the expression since we essentially just multiplied it by 1, that is, the quantity x plus the square root of 3, over the quantity x plus the square root of 3, is actually just 1. Simplifying, we should arrive at an essentially still the same but now transformed limit expression. The limit expression now reads as the limit as x approaches the square root of 3 of 1 over the quantity x plus the square root of 3. We now proceed to repeat the process of replacing x with the square root of 3. This time we should end up, not with a 0 over 0 limit, but with the square root of 3 over 6, which is our correct answer in choice A. Question number 3. Which of the following has the highest value? A. 5 times the square root of 3. B. 3 times the square root of 7. C. 4 times the square root of 10. D. 2 times the square root of 17. The correct answer is C. 4 times the square root of 10 has the highest value among the given choices. Recall your algebra topic, exponents and radicals. Let's inspect and evaluate each of the given answer choices. Since all the choices involve square roots, we can get the square of each of them, to get rid of the square root and more easily compare the numbers. Answer choice A, squaring 5 times the square root of 3 will give us 75. Answer choice B, squaring 3 times the square root of 7 will give us 63. Answer choice C, squaring 4 times the square root of 10 will give us 160. Answer choice D, squaring 2 times the square root of 17 will give us 68. From here we simply compare the results. We should easily pick out the largest as choice C. By the way, since we squared the given choices, what we compared are not the original values but their respective squares. Shouldn't we reverse the process and take the square root of the answers to compare the original values? You can do that, but that is completely unnecessary. Since we squared all of them, then we can compare their results as if we are comparing the original values. The biggest number will have produced the biggest square anyway. Question number 4. A square is inscribed in a circle with a radius of 12 centimeters. What is the area of the shaded region? A. 144 times the quantity pi minus 2. B. 144 times the quantity pi minus 1. C. 48 times the quantity 3 pi minus 2. D. 72 times the quantity 2 pi minus 1. The correct answer is A. 144 times the quantity pi minus 2. Let R be the radius of the circle. This is given as 12 centimeters. D is the diameter of the circle, which is equal to the length of the diagonal distance of the square. Since the radius is 12 centimeters, D must be 24 centimeters. Let S be the length of each side of the square. A square is the area of the inscribed square. With S as the length of each of its sides, A square must be equal to S squared. A circle is the area of the circle. We know this from formula to be pi r squared. With radius being 12 centimeters, a circle must be 288 pi. The area of the shaded region, A shaded, must be equal to the area of the circle minus the area of the inscribed square. We already know the area of the circle to be 288 pi. The area of the inscribed square is S squared. But we don't know yet the value of S. To solve for S, let's take a look at the triangle formed by two sides of the inscribed square and its diagonal length, which we earlier determined to be 24 centimeters. From the Pythagorean formula, 24 squared is equal to S squared plus S squared. From here we can compute for the value of S squared to be 288. S squared also happens to be the area of the inscribed square. So now we can finally solve for the area of the shaded region and arrive at 144 times the quantity pi minus 2 is the correct answer. Question number 5. Tanyo is 28 years older than Berto. In 6 years, Tanyo will be 3 times as old as Berto. How old is Tanyo now? A. 34 years old. B. 84 years old. C. 24 years old. D. 36 years old. The correct answer is D. 36 years old. For the solution to this, let's introduce you to a handy technique when solving age problems, the age table. Tabulate with the names of the people whose ages are being compared as rows, and the known or given points in time, usually the present or now, some point in time in the past, and some point in time in the future, as columns. Let's show you how to use this technique for the solution to the given problem. Step 1. Set up your age table. This can be a simple sketch with your pen and paper when you are in your exam. Step 2. Set up your age expressions and equations. Let x be Berto's current age. X plus 28 is Tanyo's current age. This is what we are looking for. X plus 6 is Berto's age in 6 years. X plus 28 plus 6 is Tanyo's age in 6 years. Take note that 3 times the quantity x plus 6 is also equal to Tanyo's age in 6 years, since in 6 years, Tanyo will be 3 times as old as Berto. What about the past column? Since there is no reference about the ages of Berto and or Tanyo in the past, we can simply ignore this column, or mark it as not applicable. Step 3. Since we have two expressions of Tanyo's age in 6 years, we can equate the expressions to each other. From this equation we can proceed to solve for x, which is Berto's present age. So we just solve Berto's present age to be 8. With Berto's present age, or x, already known, we can proceed to compute for Tanyo's age, which is x plus 28. We should quickly determine Tanyo's current age to be 36. We can validate this answer with the statement, in 6 years, Tanyo will be 3 times as old as Berto. In 6 years, Berto's age is 8 plus 6 equals 14. In 6 years, Tanyo's age is 36 plus 6 equals 42. 14 times 3 is 42. Correct. Note that the usefulness of your age table will become much more apparent when you are dealing with more complex age problems, involving more than 2 persons and or more than 2 points in time. So practice using your age table as much as possible. Question number 6. What is the measure of angle x in the figure shown? A. 115 degrees. B. 130 degrees. C. 132.5 degrees. D. 147.5 degrees. The correct answer is D. 147.5 degrees. Recall from your geometry that 1. The measure of a central angle is equal to the measure of the intercepted arc, and 2. The measure of an inscribed angle is half the measure of the intercepted arc. In the given figure, the central angle is given as 65 degrees. From our definition of central and inscribed angles, the inscribed angle is half the central angle. Therefore, the inscribed angle is 65 degrees divided by 2. Also, in the given figure we can see that x and the inscribed angle are supplementary angles. Therefore, x plus the inscribed angle, which is 65 over 2, is equal to 180 degrees. Multiplying both sides of the equation by 2, we'll end up with the equation, 2x plus 65 equals 360. From here, it's just a matter of solving for x. We should arrive at 147.5 degrees as our final and correct answer. Question number 7. Suppose that the function of x is equal to the quantity 3x minus 1 over x. Evaluate the inverse function for x equals minus 2. A. 1/5. B. minus 1/5. C. 7 over 2. D. minus 7 over 2. The correct answer is A. 1/5. Equating the function of x to y, we have y is equal to the quantity 3x minus 1 over x. Recall from algebra that, to find the inverse of a function we just have to switch the x and the y and then solve for y. Therefore, x is equal to the quantity 3y minus 1 over y. Multiplying both sides of the equation by y, we'll have xy equals 3y minus 1. Remember that we are now solving for y. We should arrive at y equals 1 over the quantity 3 minus x. We've just solved for the inverse function of x, so we can rewrite our resulting equation to inverse function of x is equal to 1 minus the quantity 3 minus x. Since we are being asked to evaluate the inverse function for x equals minus 2, then we replace x with minus 2 in our equation. We should quickly arrive at 1 over 5, which is our final and correct answer. Question number 8. Which of the figures below shows, or show, a pair of congruent triangles? A. 1 only. B. 2 only. C. 2 and 3 only. D. 1 and 2 only. The correct answer is B. 2 only. Recall congruent triangles and similar triangles in your geometry. By HL postulate, only 2 definitively shows a pair of congruent triangles, highlighted with green and pink triangles. The hypotenuse leg postulate, also known as HL postulate or HL theorem, states that, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the 2 triangles are congruent. Take note that this is, intentionally, a very tricky question. Visually, all 3 figures seem to show symmetry and therefore, they should all contain multiple pairs of congruent triangles. But only figure 2 has enough explicitly provided information, that is, the right angle sine and the two sides that are 10 units in length, to make an outright conclusion without having to make further assumptions. For figures 2 and 3, we will need to assume that the vertical and horizontal lines are indeed perpendicular, that is, at right angles, to each other, and that the left and right sides are perfectly symmetrical. Question number 9. In a certain school there are 12 male teachers and 10 female teachers. The ratio of male teachers to female teachers is proportional to the ratio of male students to female students. How many male students are there in the school if there are 150 female students? A. 160. B. 175. C. 180. D. 192. The correct answer is C. There are 180 male students in the school. This is a simple ratio and proportion problem. The ratio of male teachers to female teachers is proportional to the ratio of male students to female students. The only unknown value is the number of male students, which is what we are looking for. So let's solve for MS. We should easily arrive at 180, the number of male students in the school. Question number 10. For theta is greater than or equal to 0 and less than or equal to 2 pi, find the solution set of the trigonometric equation, 4 times sine squared theta minus 3 equals 0. A. 4 pi over 3 and 5 pi over 3. B. 0, pi over 3, 2 pi over 3, and 2 pi. C. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. D. Pi over 3 and 2 pi over 3. The correct answer is C. Let's solve the given trigonometric equation, 4 times sine squared theta minus 3 equals 0. We should arrive at sine theta is equal to plus or minus the square root of 3 over 2. With this, we can see that there will be 4 values of theta in the solution set. This effectively eliminated choices A and D, leaving us with only B and C to choose from. For the first solution, sine theta is equal to positive square root of 3 over positive 2. We've drawn for you its corresponding triangle in the Cartesian plane. Notice something familiar? From your basic trigonometry you should have immediately recognized that square root of 3 over 2 is equal to the sine of 60 degrees. Since the values of theta in the answer choices are all expressed in radians, we need to convert 60 degrees to radians, which is pi over 3. This is the first solution in our solution set. For the second solution, sine theta is equal to negative square root of 3 over positive 2. Again, we've drawn the corresponding triangle in the Cartesian plane for you, and worked out theta to be 120 degrees, or 2 pi over 3 radians. This is our second solution. For the third solution, sine theta is equal to negative square root of 3 over negative 2. We should arrive at a theta of 240 degrees, or 4 pi over 3 radians. Lastly, for the fourth solution, sine theta is equal to positive square root of 3 over negative 2. The resulting theta for this should be 300 degrees, or 5 pi over 3 radians. Therefore, our solution set consists of pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. You have just completed UPCAT Reviewer number 5, which featured questions for the UPCAT Mathematics Proficiency subtest. If you wish to watch more UPCAT reviewers for the UPCAT Mathematics Proficiency subtest, check out our UPCAT Mathematics Proficiency Reviewers playlist. Check out also our other UPCAT playlists for other reviewer topics. If you haven't done so yet, please don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful, and feel free to share it to anyone who may also benefit from it. We wish you all the best on your forthcoming UPCAT, and we look forward to your exciting days as an ISCO or ISCA. Padayon.